Okay, class, we're about to start lesson 12, divide polynomials. Divide polynomials by a number. The mathematical reasoning test will sometimes ask you to simplify a polynomial that is written as a fraction. To simplify, divide the numerator and denominator by a common term. A common term can be the following: a number, a variable with a number as a coefficient, a more complicated expression. You may need to factor the common term out of the numerator or denominator before you can do the division. For example, example 1, simplify. We got 3x plus 6 over 3. Now, when we have this here, we have 3x plus 6 over 3. You see here that they factor out a 3 because 3x and 6 has 3 in common. And they factored out a 3 and they ended up with x plus 2. But let me show you what's not shown here. When we add 3x plus 6 all over 3. Now, you look at 3x and you look at 6. Now, remember when we did the greatest common factor? We did that, I believe, in lesson 10. So what I'm going to do with this, with these examples, I'm going to go in depth on how you're supposed to do this, because I'm not going to be able to do this for every problem. So what we would do here, we would look at the numbers. We're not concentrating on the variable yet. I'll get to how you would factor out a variable. But the numbers, if we do the greatest common factor of 3 and 6, remember we did prime factorization. 3 is already prime, but 6 breaks down to 2 and 3. So the prime factorization of 3 is 3, and the prime factorization of 6 is 2 times 3. Now they only have 3 in common, so their greatest common factor is 3. So that is what you factor out. You have your 3 here, and then your parenthesis. Okay, now, I remember telling you all in lesson 10 that when you factor out in your head, this is what goes in the parentheses first. It'll be what you originally had, that 3x plus 6. But this will be divided by what you factored out. I'm sorry I messed up that x. But this would be 3x over 3 and 6 over 3. So when you do this, this would be 3x over 3. These 3's will simplify out and leave you x. Plus 6 over 3 is 2. So you have 3 times x plus 2 all over 3. These 3's will simplify out, and your final answer would be x plus 2. Now, I know I went extra steps than what they showed here, but what I want you to see is everything that goes into this problem. And some of this stuff you have to do in your head, but if you need to write it out, fine. Because as you see here, they didn't write out that you were finding the greatest common factor. Okay, now, let's look here at this second and third example. It says divide polynomials by an expression. Dividing a polynomial by an expression is really no different from dividing by a number. You need a common term in the numerator and denominator, and you may have to factor out that common term, including any variable, before you could do the division. So now they have simplified. We had 25x cubed minus 45x squared all over 5x. Now, at this moment, we're not going to concentrate on the variables. Let's look at the numbers. 25 and 45. We're going to do the GCF. 25 and 45. 25 breaks down to 5 times 5. So, you have 5 times 5 is the breakdown of 25. 45 is 9 times 5. The 5 is prime. And then a 9 you break down to 3, 3. So you have 3 times 3 times 5. Now the only thing they have in common, the greatest common factor is 5. So their GCF is 5. So we know we're going to factor out a 5 here. So we're going to factor out a 5. We're going to have our parenthesis and 5x at the bottom. Okay, now, unlike the first problem we had an x with the first term, but no x with the second term. In this problem here, we got an x with both terms. Now, I want you to listen to this very, very clearly. Whenever you have both variables, whenever you have the variables and they are the same, they have the same base. Now, let me go back and refresh your memory. Whenever you have a variable to an exponent, the variable itself is the base and the exponent is the exponent. So when I say that you have the same base, I'm talking about the same variable. Their exponents can be different, that's fine, but we have the same base, which is the variable. Now the exponent, what you factor out is this here. Whichever exponent is the lowest. You don't have to do a greatest common factor, but when you look at these exponents, the exponents that's the lowest is 2. So you will factor out x squared. Okay, so now you understand how we got the 5. Now to get the x squared, both terms must have the variable, and then you would take the variable that has the lowest exponent. Now again, in your head, with what goes inside this parenthesis, you would take the 25x cubed and you would divide it by what you factored out, which is the 5x squared, minus 45x squared divided by 5x squared. Now this would be 5x squared, and in parentheses, 25 divided by 5 is 5. X cubed divided by x squared. Now, when you're dividing exponents, remember when we multiplied exponents, and I showed you this in the previous when we were multiplying monomials. X squared times x to the third. They have the same base. You carry over the base. Then you add the exponents. 2 plus 3 is 5. So we know x squared times x cubed is x to the fifth. So when you multiply with the same base and add the exponents, that would mean when you divide with the same base, you would subtract the exponents. X cubed over x squared, you add x, and then you would subtract the exponents. 3 minus 2 is 1. So your answer would be x to the first or just x. Now we're going to take that same knowledge over here. X cubed over x squared is just x. You don't have to write to the first power. Now minus 45 divided by 5 is 9. X squared divided by x squared, they'll simplify each other out. So in this parenthesis, you have 5x minus 9, all divided by 5x. Now, one thing I didn't say in the first example is this here. Before we simplify this whole fraction, if you took this 5x squared and multiplied by this parenthesis, it should give you what you originally started with. 5 times 5 is 25. X squared times x is x cubed. 5 times a negative 9 is negative 45, and you will bring over your x squared. So that lets us know that we have not changed the problem. Now we're going to simplify. These 5's will both simplify each other out. Now, x squared and x would simplify each other out as well. So x squared and x, we know that that would leave us just x. So we would have x here. So then we would have 5x minus 9. So we will multiply these, and this will give us 5x squared minus 9x, because we want our final answer to not have the parenthesis. Okay, now, we're done with example 2. Now, example 3 looks a little different. So with example 3, it says when a numerator has 2 added or subtracted expressions that both include the common term, it may be easier to split the polynomial into 2 separate fractions and simplify them separately. Doing it this way will help you keep straight exactly which terms you can cancel. So let's watch this. We had x times x plus 7 minus 3 times x plus 7 all over x plus 7. Now again, we're going to concentrate on our numerator. Now if you notice here, we had x and x plus 7 minus 3 and x plus 7. I want to show you something before we do this problem. What if I had xy minus 3y all over, let's just say x minus 3. Let's just do it like that. xy minus 3y. With these terms, remember what I told you before. If they have the same base, same variable with the same base, then you take the one with the lowest exponent. Both of these have the same exponent, right? So that means we would factor out the y. And then in a parenthesis, remember, in your head, in a parenthesis, you add xy over y, because that's what you simplified out, minus 3y over y. Now, when you simplify this out in a parenthesis, the y's will simplify out, leave you x, minus the y's will simplify out, leave you 3, all over x minus 3. Now, listen, I'm going to stop here, because my point is this here. When you, I may have to stress this out because I want, okay, cool. Okay, now, you notice here both of these had y. They were the exact same. And you see I pulled out the y. Aren't these two parentheses the exact same? So that means you will pull out this parenthesis, just like you pulled out the y here. So you will pull out x plus 7. Okay, now I'm going to put the bottom here. Now we have to determine what to do with what's left out here, this x and this minus 3. Now if we look here, when we pulled out this y, we still had an x and a minus 3 here, right? Didn't we end up writing that here? We pulled out what they had in common, and then we wrote everything that's left inside its own parenthesis. So we do that same thing here. We write everything that's left in its same parenthesis. Now, if you need to rewind this to hear me say that again, do it. But I will say it one more time. Just like here, when we pulled out our y, everything that was left, which is the x and the minus 3, went in its own parenthesis. So we pulled out our x plus 7. What's left is x minus 3, and it goes in its own parenthesis. Now that we have this, since it's multiplication up here, these x plus 7s can simplify out. And this will leave x minus 3. Okay, now, it says here, it says undefined expressions. When the denominator of an expression equals 0, the expression is undefined. What is the value of this here when x is equal to y? Now listen. Let me just simplify this very simply. If you get something, say you had up top x squared plus 2xy plus y squared, and let's say that your bottom end up equaling 0, because that's what all this is saying. If your bottom end up equaling 0, then your answer here is undefined. Now that's only if the top doesn't equal 0 too. But if it's just your bottom that equals 0, your answer is undefined, no matter what happens to the top except for if it equals 0. All right, now, that is enough for the examples. Let's go to some actual problems here. Now, we got quite a few problems, but we're going to get through them. So, let's start out. It says to simplify, divide each polynomial by a number. You may need to factor the numerator and or denominator to find a common term. Okay, I want to read the directions for B2. It says divide each polynomial. Decide whether it is easier for you to divide the original numerator by the common term. So basically, we have the same thing that we had before as far as with the directions. So we could do that. Yeah, we could do this and solve this. Okay, now, I just noticed there was one method that I did not show you. So let me go back and show you this method. This is another method you can use. Going back to example 3. Example 3 showed another method. I showed you one method where you're factoring out, and that will come in handy later. But they show you this other method. Let's take this same problem here where it had x times x plus 7 minus 3 times x plus 7 all over x plus 7. Now, instead of them factoring out the x plus 7 like I did, what they did here was, since these are two terms, we could divide both of these terms by individually by what we had in the bottom here, what we had in the denominator. So we could divide both of these by the same denominator. Now, let me show you this. If I had 5 minus 4 all over, well, let me get something easier. Let's say I had 4 minus 2 all over 2. This is the same as 4 over 2 minus 2 over 2, isn't it? Because remember, when you subtract, you have to have the same denominator. And then you would carry the denominator over, and then you would subtract the numerator. That is the same thing we had here. Exact same thing. So now, these x plus 7s will simplify out, and that will leave us x. These x plus 7s will simplify out, and that will leave us a minus 3. So now, that's another method you can use for these math problems. Now we go back. Go back here. So they want us to solve this. So number 1, we have 2y plus 30 divided by 2. Now here, they want you to factor the numerator and denominator. They don't want you to separate it like I just showed you. So basically with 2 and 30, now I'm only going to do the greatest common factor, showing that maybe once or twice more, because we did that extensively, I believe in lesson 6 it was. So it was lesson 6. So we do the greatest common factor. So we had the greatest common factor of 2 and 30. So we know the greatest common factor of 2 is 2 because that's already prime. 30 can be broke down to 2 and 15, and then 3 and 5. So that'll be 2, 3, and 5. So the only factors they have in common here is 2. So the GCF is 2 here. So we will factor out a 2. And then remember, in our mind, that'll be 2y over 2 plus 30 over 2. So this will give us 2, and in parentheses, y plus 15 all over 2. These 2's will simplify out, and y plus 15 will be your final answer. Now for problem number 2. Now again, if you want to use the greatest common factor, you're free to do that. You could do that to the side. I'm just not going to do it. I gave you the model, so you know what to do now. 7x and 21, the greatest common factor they have is 7, and then that will leave us x plus 3 all over 7. Now again, in your head, after you factor out the 7, you would take 7x divided by 7, which will give you x, and then you would take 21 divided by this 7, which will give you 3. So whatever you factor out here, you divide both of these by that value to get what's in the parentheses. So these 7's will simplify out and leave you x plus 3. Now number 3, we have 4x plus 20 divided by 4. 4x and 20 has 4 in common. And Then in parentheses, you add x plus 5 divided by 4. These 4's will simplify out, and you add x plus 5. Okay, problem number 4. You add 3a plus 3b all over 3. These two you can factor out of 3, and you add a plus b all over 3. These 3's will simplify out and leave you a plus b. Now, let's look at number 5. We have 11x squared plus 22x all over 11. Now we can factor out 11, and we have x squared plus 2. Oh, you know what? We're supposed to factor out, okay, both of these terms have an x in it. So we was also supposed to factor out an x as well. So this right here, we could factor out 11x. Because remember I told you, when they have the same variable with the same base, you take the variable with the lowest exponent. So when you divide 11x squared by 11x, you will have x. 22x divided by 11x will give you 2 all over 11. These 11's will simplify out, and you add x times x plus 2, which is x squared plus 2x. Now number 6, you add 26x squared plus 39x plus 13 all over 13. Now 26, 39, and 13, they all have 13 in common. But if you notice here, all of these do not have the variable, so you cannot factor out a variable. Now, 26x squared divided by 13 will leave 2x squared. 39x divided by 13 will leave you a positive 13x. And 13 divided by 13 will leave you positive 1. Okay, now, these 13's will simplify out, and this will give you 2x squared plus 13x plus 1. All right, now number 7, 8, okay, number 9 is a little different, but 7 and 8 is basically the same as what we've been doing. So I'm going to skip over those and go to number 9. Number 9, we have 48x plus 32y all over 32. Now with 48 and 32, the greatest common factor they have is 16. And these variables are not the same. They don't have the same base, so you don't have to factor out a variable. So now, 48 divided by 16 is 3, and you bring over your x. 32 divided by 16 is 2, and you bring over your y. So now 16 and 32. 16 goes into 16 once, 16 goes into 32 twice. So your answer here, 1 times anything is whatever you're multiplying it by. So it'd be 3x plus 2y in your numerator and 2 in your denominator. Okay, now, we need to, all right, now, under normal circumstances, this would be your final answer. But you look here, if we separated this, these 2's would simplify each other out. So we have to separate it as 3x over 2 plus 2y over 2. These 2's will simplify out, so you add 3x over 2 plus y. And that will be your final answer. 3x over 2 plus y after these 2's simplify out. Okay, now, let me look at number 10. Number 10, we had 9a minus 15b over 12. Now, 9 and 15, the greatest common factor is 3. And that'll leave us 3a minus 5b all over 12. 3 goes into 3 once, 3 goes into 12 4 times. So it'd be 3a minus 5b all over 4. And you can't simplify any of these terms anymore, so this would be your final answer. Okay, now, number 11. We have 6b plus 24c all over 18. Now, 6b and 24c has the greatest common factor of 6. So that'll be b plus 4c all over 18. Now, 6 goes into 6 once, 6 goes into 18 3 times. So our final answer would be b plus 4c all over 3. Now we go here to problem number 12. Problem 12, we had 25a plus 5b plus 15c all over 10. Now, if you look in your numerator, the greatest common factor of these three terms is 5. So we factor out a 5, and we have 5a plus b plus 3c all over 10. 5 goes into 5 once, 5 goes into 10 2 times. So we will have 5a plus b plus 3c all over 2. And that would be your final answer for problem 12. Okay, now, we scroll down. All right, so now we go here to B. It says divide each polynomial. Decide whether it's easier for you to divide the original numerator by the common term, as in example 2, or whether to split the numerator first, as in example 3. So we have some choices here. And what I'm going to do what I think is the easiest way of doing this, since they gave us a choice. So let's look at 13. 13, we have 18x squared plus 6x all over 3x. To me, I think this would be easier split. So we have 18x squared over 3x plus 6x over 3x. 18 divided by 3 is 6. X squared divided by x is x. Plus 6 divided by 3 is 2, and these x's will simplify out. So that took care of 13. Now 14, we had 10x squared plus 6x all over 2x. I would split that as well. 10x squared over 2x plus 6x over 2x. 10 divided by 2 is 5. X squared divided by x is x. Plus 6 divided by 2 is 3, and the x's simplify out. Now basically, 15, 16, and 17 is basically the same thing, but I'm going to do 17. So 17, we add 38xy plus 38x all over 19x. So I split this up, 38xy over 19x plus 38x over 19x. 38 divided by 19 is 2. These x's will simplify out and leave you y. So that's 2y. Plus 38 divided by 19 is 2, and these x's will simplify out. So your answer here will be 2y plus 3. Now 18, now 18, which is a nice problem. It says 3x plus 18 over x plus 6. Now this here, I would not split this up because this would be 3x over x plus 6 and 18 over x plus 6. You wouldn't be able to simplify that. I would go with the greatest common factor like we did in previous problems. So here you can factor out a 3, and you would be left with x plus 6 all over x plus 6. These x plus 6's will simplify out and just leave you 3. Okay, now 19, 20, 21, 23, and 24 are all the same type of problem. So again, 19, 20, 21, 23, and 24 are the same type of problem. So what I'm going to do 19 and 24, and then I'll come back and do problem 22. So problem 19, we had x times x plus 4 minus 6 times x plus 4 all over x plus 4. Now, what I would suggest is what I told you all before. We could factor out this x plus 4, and everything that's left will go in its own parenthesis, which is x minus 6, and that's all over x plus 4. These x plus 4s will simplify out and leave you x minus 6. So that's it for problem 19. Now, again, if you need, you can rewind it, pause it, and then you can copy down problem 19. Now we jump to problem 24. We have a times b plus 3 plus 3 times b plus 3 all over b plus 3. Now again, we'll do this the same. We could pull out the b plus 3, and then the things that's left, a plus 3 will go in its own parenthesis, all over b plus 3. The b plus 3's will simplify out, and you add a plus 3. That'll take care of problem 24. Now I said I would come back and also do problem 22. So let me do 22. 22, we have 22x squared plus 66x all over 11x. Now what we would do here is we would take out the greatest common factor. The greatest common factor of 22x squared and 66x is actually 11x. Well, actually, hold on. Let me put it here. It's actually 22x. And then 22x squared divided by 22x is x. 66x divided by 22 is 3. All over 11x. These x's will simplify out. 22 divided by 11 is 2. And then you add x plus 3. Now, typically, they don't want you to have your final answer as 2 times a parenthesis. So what you would do is multiply this out, and it would be 2x plus 6. And that'll be your final answer for 22. Now, we come down here to 25 through 28. So we go here to problem 25. It says choose the one best answer to each question. Which of the following is equal to 21a plus 14b over 7? So basically they want us to simplify this. Now if you notice here, a and b are different variables, so they're not like variables. So you cannot factor out a variable. But here, the 21 and 14, their greatest common factor would be 7. So you can factor out a 7, and then that would leave us 3a plus 2b all over 7. Now again, we took this problem here. If you need to write that problem down, fine, right? Well, I probably should have wrote it down. So let me write it here. So this would have been 21a plus 14b all over 7. And I'll put it equal. So this is first, this is second. Now these 7's will simplify out, and you have 3a plus 2b. Now 26. James has 27x apples. Rachel has 51y oranges. And Glenn has 60z peaches. Which of the following expressions represent the average number of pieces of fruit that James, Rachel, and Glenn have? Okay, which one of the expressions represents the average number of pieces of fruit that James, Rachel, and Glenn has? Okay, so let's take a look. So 26, we had 27x plus 51y plus 60z. Now they asked us for the average. Now remember, I told you with average, you add up the values and then divide by how many values you have. So it was 3. So it's 3 values we have. Okay, now 27, 51, and 60. We're not worried about the variables because none of the variables are the same. So 27, 51, and 60 all has 3 in common. So we can factor out a 3, and then we can, so 27, that'll become 9x, and 3 goes into this here, a positive 17y times, 3 goes into 60, 20z times, all over 3. These 3's will simplify out, so your final answer is 9x plus 17y plus 20z. And that would be D. Now what I didn't do, I didn't mark the letter for 25. That should have been C. Okay, now, problem 27. Which of the following expressions is equal to, and they give us these values here. Now, let me see. So let's go through 27. We have 2z squared minus 12z plus 2 times z plus 4 minus 8 all over 2z. Now, first of all, we have to do some multiplication here. And we have to combine like terms when we can. So we got 2z squared minus 12z plus 2 times z is 2z, and then 2 times 4 is 8 minus 8 all over 2z. Now we combine the like terms. So we had 2z squared, negative 12z plus 2z is a positive 10z. And these 8's will simplify each other out to 0 all over 2z. Now we can separate this and divide both of these by 2z. We can divide both of these by 2z. The 2's will simplify out. Z squared divided by z is just z. 10 divided by 2 is 5, and the z's will simplify out. So our answer here is just z plus 5. And that's interesting. Oh, you know what? I made an error here. It's supposed to be z minus 5 because negative 12z plus 2z is supposed to be a minus 10z. So this right here should have been subtraction. So it was a minor error, but the answer is z minus 5, which is A. Okay, number 28. For what values of A is the expression A times 4A minus 16A over A times absolute value of A plus A squared? Okay, so now, what we have to do is this here. We don't need to concern ourselves with the numerator. It's the denominator that we're concerned with. Remember, when we make that denominator equal 0, as long as we don't make the numerator 0, as long as the denominator is 0, we're fine. Okay, so now if we look at the denominator, if we put positive 4 in our denominator, we're going to have a positive answer. So that doesn't work. So now let's look at C for 16. We know 16 wouldn't work either if we put it in for A. So now we're left with B and D. Remember, they said the best answer. So if we look here, it says A is less than or equal to 0, or A is greater than or equal to 0. Now listen. Let's concentrate on what less than 0 means. Less than 0 means negative numbers. Greater than 0 means positive numbers. Okay, so we know with B and D that they're saying it's going to be 0 plus either all positive numbers or 0 and all negative numbers. We just proved that positive numbers didn't work with the 4 and 16. So we know that it can't be D, so it would have to be B. So B is A is less than or equal to 0, and that is our final answer, and we're done with lesson 12, and this will be uploaded to YouTube. Have a wonderful day.